Hiya, for you are up and ready to join me for your maths skills lesson. So thank you very much, and I'm really excited for this 3-part lesson. And before we get started on our first part, we've got some key vocabulary that we should be trying to use to support our explanations with our mathematics for today. For you to explain, that might be helpful if you have a partner to be sitting next to and somebody to be talking to. So adults, that might be you. But also please have a pen and paper to be making some calculation notes to help you keep up with some of the maths that we're doing today. Let's get started. The key vocabulary we'll come across is partition, part, whole, thousands, hundreds, tens, ones, nearest multiple, half, equal, double. Great, so if you could be using that really specific vocabulary to support your explanations, that would be fantastic and really help you develop that understanding of maths. Let's get going. So we are going to be starting with partitioning numbers, and you're going to help me complete the model on the left of the screen. Then I'm going to reveal a separate model for you to work on your own. Okay, so let's think out loud. I'm going to partition into thousands, hundreds, tens and ones. How many thousands have I got? 3,000. Oh, who can read my number? Should we start off with trying to read it? 3,188. Fantastic. So in 3,188, there's 3,000. Nice and easy. 188. Great. Nice and easy. 3,188. So in 3,188, there are how many thousands? Yeah, there are 3,000s, there are 100, there are 8 tens, and there are 8 ones. Oh, fantastic. Now, can you have a go at doing this model by yourself? Off you go, nice and quick. Great, we should have that done now. What was the number? It was 4,695. Well read. So we know that's 4,695. We know in 4,695 there are 4,000s, there are 600s, there are 9 tens, fantastic, and there are 5 ones, fantastic. 4-digit numbers broken down into very manageable parts for us to work with. Help me out. This time I've got the parts, I haven't got the whole. We've got 5,766. Oh, fantastic, nice and easy. 5,766. We know in 5,766 there are how many thousands? There are 5, there are 700s, there are 6 tens, and there are 6 ones. Great, thank you for your help. Now you're up, nice and quick. Let's go. You know the parts. Let's read the parts to help us get to the whole. 9,473. 9,473. Brilliant, thinking about those place value columns. So in 9,473, there are how many thousands? There are 9, there are 400s, there are 7 tens, and there are 3 ones. Fantastic. Now, help me out. This time, when we're reading our parts, 2006, 450, 450, 2006, they don't slot into their place value columns as easy. So we're going to have to combine some of the parts to help us make more sense of it. So 2006 and 2006, what's double 2,000? Because we've got 2 of them. It's 4,000. Double 6 is 12. 4,012. So if I get rid of that, put 4,012 as a part, get rid of that. Right, lovely. So I've got 4,012 and 450 and 450. 400s combined gives us 800, and the 50s combined gives us another 100. 800 and 100 is fantastic. It is 900. So we've got 4,012, 900, 4,912. Thank you very much for your help there. So in 4,912, there are 4,000s. There are how many hundreds? Yeah, there are 900s. There are 110, and there are 2 ones. Fantastic for your help there. You've got one similar. Think about the parts, combine the ones that can make it a little bit easier for you, and combine the double that you might see. Off you go. Fantastic, I'm back in. Which parts did you combine? Yeah, because when we were reading them, 3,040, 3,040, 350, 350. Looking at the 350, 300 and 300 is 600, 50 and 50 is another 100, 600 add another 100 is 700. Great. 3,000 and 3,000 is 6,000, 40 and 40 is 80. So we've got 6,080 instead. So we've got 6,080 and 700. We've got 6,780. And in 6,780, there are 6,000s, there are 700s, there are 8 10s, and there are 0 1s. Not many ones at all, was there? Lovely. Your turn to help me out. So this time I have the whole, and I've got a couple of parts, and I've got a couple of parts spare. There's probably more than one way to do this, but let's have a little look and see what we've got so far. We've got 3,545. 3,545. When I look at 3,500, I see 7,090. 3,500. What's double 35? Yeah, it's 70, isn't it? So I've had 2 of those the same. Let's have a little look at it. 3,000, 3,000 is 6,000. 500, 500 is 1,000. 6,000 and 1,000 is 7,000. So now I've got 7,045. What do I need to get me to 90? 45. 5 gives me 50. 60, 70, 80, 90. 4 10s and 5. 45. Yes, some of you might have spotted, because you're so good at your double and halves, actually 45 is half of 90. So we could have a part of 3,500 and a part of 45 to give us that whole of 7,090. There are other options that you could have done, but let's look for those connections and really think more mathematically. So in 7,090, there are 7,000s, 0 hundreds, 9 10s, and 0 1s. So fantastic. Your turn. Remember to look for those connections to help. Off you go. Great, I'm back in. So what does the whole read? The whole reads 6,570. And what parts do we have? 250, 250. We might have recognised 200 and 200 gives us the 400, and then the 50 and the 50 gives us another 100, meaning we have our 500. So that's our 500, fantastic. So now we just need the 6,000 and we need the 70. Okay. So some of you might have gone straight away and just gone 6,070. Fantastic. Some of you might try and partition them off into equal parts like I did, meaning we would need 3,035. So 3,035 and 3,035 is to half 670. Got that odd 10, half the 10, half the even rest of tens. Helps us out there. So in 6,570, there are 6,000s, there are 500s, there are 7 tens, and there are 0 1s. Fantastic for your health there. We've got some incomplete part-part whole models now. Some of them are a lot more open than others. First of all, I would like you to start off by partitioning it into your place value columns. Then I would like you to solve the other ones thinking about relationships. And finally, I am asking you to make sure all of these 4 parts are equal. They all must be the same. I wonder what that might be the same as. Off you go. Pause the video if you would like more time. We're going to start off and we're going to partition these off into their columns. We've got 8,316, 7,329. Fantastic. Here we've got 225, 225, meaning we've got 450. So we've got these 2 parts. So then we might partition this off into the 6,000 and the 4. Some of you might have gone 3,002 and 3,002 using your half facts. That would have been a nice challenge for you. This time we've got 5,000. What is left over then? We've got 5,000. The number reads 6,753. Meaning we've still got 1,753 left. So you need to partition 1,753 into whichever way you feel is effective for you. You might go for 1,700, 50 and 3. There are other ways you could do that, so get your adult to check your partition in there. Let's see what we've got. We've got 229 to help us get to the whole of 999. So what are we missing? So we haven't got all the hundreds, we're still missing 700. We've got the 9, which is great, and we've only got 2 of the 10s, so we're missing 7 10s. So meaning we could have 770 there. So look at what you have to figure out what you don't have. And then finally, for all these parts to be equal, we must partition 4,804 into 4 equal parts. So knowing your 4 times tables is going to be really helpful. How many thousands can be divided? Yes, it'll be 1,000. How many hundreds? Yes, you get 2 hundreds each. And finally, any tens? Tens, there are no tens there to share. And there are 4 ones. So we would get 1 1 each. So 1,201, 1,201, 1,201, 1,201. So fantastic, you managed to spot that relationship. This is exactly the same as quartering a number. So quartering a number, find a quarter of a number, or dividing the number by 4. Okay, so fantastic, you managed to spot what I was asking of you there. Now, activity 2, so part 2 of our lesson today. We're going to look at some variation facts. These variation facts are to be solved by using the fact that we know is true. Okay, so if we know that 6 times 11 equals 66, which we do, we can solve many other facts as a result of that. Okay, so help me out here. 6 times 11 is 66, so 11 times 6 is 66. Fantastic. They're completing some of the fact family facts that we know. 66 shared by 11 is going to leave us with 6 in each of those 11 groups. Can we see the inverse calculation there? The relationship is very, very clear. If we know 66 divided by 11 is 6, we also know that 66 divided by 6 is, yes, 11. So fantastic. We swap the numbers in. But remember, when we're dividing, we're always starting with those smaller numbers and we partition off into groups. Finally, from this column, we've got 6 times 22. You can see there's been a change in the relationship. 6 is the same, however, 22 is a double fact of 11. So meaning, if that's been increased by 2 times, means our answer must increase by 2 times. So 2 lots of 66, 60 times by is 120. 120, add the 12 of the doubled 6, gives us 132. So fantastic if you manage to help me solve that one. Now we've got 60 times 11. What's changed from our fact? What's changed from our fact? Yes, we've got 10 times more. So actually, it's 6 tens times 11. We know 6 times 11 is 66. But to make it 66 tens, we had our 0 one, so we've got our 66 tens there. This calculation here, 110 times 60, both values have increased by 10. So 10 times by 10 times, what's 10 times 10? It's 100. So our product increases by 100 times as well. So now we would have 6,600. Brilliant. Well done. Then finally, moving on to our two final division facts. So we've got 660 divided by 11. Let's have a little look at this. 660 divided by 11. What do we think has changed? Yes, this is 10 times more, but the answers managed to stay the same. Okay, so what's going to happen to this? We're going to have to divide that by 110. So we've had to increase this by 10 times, because when we have a number, 660, and we're going to divide it and our product equals the same as that, we must divide it into more to get that smaller product. Fantastic. Now we've got the 660, but this time our product is 60, so it is that 10 times value, meaning our divisor there can be 11. Fantastic. So 660 divided by 11 is going to give us 60 in those groups of 11. So well done if you managed to solve those calculation connections. We've done these facts together. Remember, I was looking at all the relationships. I didn't have to start from the beginning, counting my 6s, counting my 11s, dividing. I didn't have to do any of that. I used the relationships of the numbers I know. So you spot the relationships and solve these calculations. Off you go. Pause the video if you'd like more time. So we know 2 times 12 is 24, so we know 12 times 2 is also 24. We know the division, yeah, it's going to give us 2. 24 divided by 2 will give us 12. What's the relationship? 24 times 2? Yeah, we've doubled this one, meaning we're going to have to double that, which is 48. 120 times by 2. 120 times by 2, what's happened? What's changed? Oh, this has gone 10 times more. So meaning this is going to have to increase by 10 times more. Oh, we've increased by 10, we've increased by 10, meaning we've increased by 100. So 24 times 100 is going to be 2,400. Looking at the division number sentence, I think we're matching up with this one. So actually, instead of 24 divided by 2, we get 120. So this is 10 times more. This is still 10 times more, meaning that this mustn't have changed. But now this time, 2400, how are we saying that? 2,400, fantastic. Divided by something equals 2. So let's have a little look. Yeah, we're matching it up with this calculation. What's happened? It's become 100 times more. So meaning this must also be 100 times more. So we've got 2,400 divided by 1,200 will give us 2. So 2 groups of 1,200 will give you that 2,400. Well done if you managed to get those calculations correct. What I'd like you to do now, I have given you the completed fact, but I haven't given you other facts that are connected. I would like you to figure out those other facts that you know because you know that fact. Off you go. Right, great. Hopefully we've got some facts we know. 7 times 9, 63. Great. If we start with 63 and we divide it by the 9, we'll get 7. 63 divided by the 7 will give us 9. Fantastic. So we've got our fact family there. They're our main facts we know already. Right, let's think about if we times one part of it by 10. Yeah, our product's going to increase by 10. What happens if times the other side by 10? Yes, our product still increases by 10. We increase both sides by 10, meaning our product now increases by 100. So well done if you manage to solve that. And we can then use the inverse to solve any of these facts. So 630, we say divided by 7 must be 9. What happens if we go 6,300 and divide by 90? Yeah, we'll connect it with that fact. We get 70. There are other facts that you will know, so please feel free to check with your adult of any of those facts that you have done and make sure that they are correct. Now, we are going to move on to our third activity, which is about rounding. And at first of all, we're going to be asked to be rounding to the nearest multiple of 10. Okay, we're very, very good at counting in 10, so 10, 20, 30, 40, 50, 60. But with some of these numbers being 3 digits, we need to think of 10s as 610, 620, 630, 640, 650, 660, so on. We might start at 800 and count tens, 810, 820, 830, 840. And we're going to try and picture where this number might lie in between its nearest multiples, so then we can decide whether we need to round up or we round down. Okay, but remember, the rule that we work with is if it's 4 or below, we round down, 5 and up, we round up. Okay, so 4 and below, we round down, 5 and up, we round up. Okay, let's have a little look. So we're rounding the number to the nearest multiple of 10. So when I'm looking at the nearest multiple of 10, I've got 640. So I've got 640. That's my first multiple of 10. 640. Because when we round down, that's the least the number it's going to go to. The next multiple of 10 will be 640, 650. So now I need to decide whether this number here, 648, needs to round down to 640 or to round up to 650. And to help me do that, because I'm looking for the multiple of 10, I'm going to look in my ones column. So 640, 641, 42, 43, 44, 45, 46, 47, 48. So 648. Which number is it closest to? Which multiple of 10 is it closest to? It is closest to 650. So we would round this number up to 650. So when rounding 648 to the nearest multiple of 10, we round down to 640 or we round up to 650. So 8 ones tells us to round up. Fantastic. So being 8 ones tells us we're closest to this multiple of 10 in comparison to this multiple of 10. Great. I want you to have a little go of this problem here. So you are rounded to the nearest multiple of 10. Your number is 823. So think about what that first multiple will be and what the next multiple will be, and decide whether you're going to round down or round up. Off you go. Right, great, let's have a little look. So our nearest multiple of 10 is 820. Yeah, so it reads 820. So that's telling us the multiple of 10 that is before. So on 820. The next multiple of 10 will be 820, 830. Fantastic. So we've got 820, then 830. And along this number line, we'd have 821, 822, 823, 824, 825, 26, 27, 28, 29. So 823 is actually going to fall about here. So when we looked, we're going to the nearest 10. We look now ones column. What does it tell us? 3 means it's closer to 820, meaning we need to round down. Fantastic. So that's why the rule works, because we can visually see 823 is closer to this multiple of 10, 820. So if I just get my rubber and get rid of this for a second, we put that information into that problem. When we round 823 to the nearest multiple of 10, we round down to 820 or round up to 830. Then the 3 ones tells us to round down. Fantastic if you manage to solve that. Again, another multiple of 10. You're going to help me with this problem. So we've got 341, meaning my closest multiple of 10, 340 to start off with. And the next multiple of 10 would be 340. 50. Fantastic. Let's picture that number line. Where would my numbers be? 340, 341. Oh, there it is. 341. Which multiple of 10 is it closest to? It's certainly going to be closer to 340. So when rounding 341 to the nearest multiple of 10, we round down to 340 or we round up to 350. The ones tell us to round down. So 4, 3, 2, 1 tells us to round down because we can see we are certainly closer to that multiple of 10. And 5 and upwards, we would round up because we'd be closer to that multiple of 10. The rule applies to the 5 because we know that's directly in the middle. Your turn to use this method with this problem here. Still working with the nearest multiple of 10. We've got the number 924. Think about that first multiple of 10 and then the next, and then place it on the number line to figure it out. Off you go. Right, we're back in. Let's have a little look. So we've got 924. So how many tens we've got? Yes, we've got 92 tens if you look. 92, 920. So we've got 920 there. The next 10 would be 920, 930. We think about our numbers on our number line. 921, 922, 923, 924, 925. And so on. 924 would just go just before the halfway point. So where do we round? Do we round up or do we round down? We can visually see we are closer to 920. So when rounding 924 to the nearest multiple of 10, we round down to 920 or round up to 930. The 4 ones tells us to round down. So that's why we say 4, 3, 2, 1. We round down because we can see that part of the number line is closer to that multiple of 10. Fantastic, you managed to solve that one. This time, the problem we're going to work out together is rounding the number to the nearest multiple of 100. So we are going to have to count now hundreds. So 100, 200, 300, 400, 500, 600, 700. But we've actually got thousands in there. And we know thousands can sometimes include hundreds. So here we're going 3,100, 3,200, 3,300, 3,400, 3,500, 3,600. Okay, so keep that in mind whilst we're doing this activity. So we are rounding down or up to the nearest multiple of 100. How many hundreds have we got? We've got 3,400. So we've got 3,400, meaning our next 100 is 3,400, 3,500. That's our next multiple of 100. So we've got 3,400, 3,500. So here, if we think about it, we're going to have 3,410, 3,420, 3,430, 3,440, 3,450. Just pop that there so we know. So whereabouts is 3,400? Oh, you can help me out. How do I write 3,450? Correct me, come on. 3,450. That is much better, thank you. So let's have a look at 3,461. Where's that going to lie? Is it going to be before 3,450 or after 3,450? Yes, it's going to be after. So meaning 3,461, is it closest to the multiple of 3,400 or closest to the multiple of 3,500? It's closest to the multiple of 3,500. So we're looking at our hundreds column, and our tens, the one to the right, tells us we are closer to the multiple up, so we're going to round up. So when rounding 3,461 to the nearest multiple of 100, we round down to 3,400, we round up to 3,500, but the 6 tens tells us we round up to 3,500. So well done if you managed to solve that with me. Now you've got this problem to solve yourself. You are going to be rounding to the nearest multiple of 100 again. So thinking about it, 9,400, 9,000. Off you go. Think about where you need to round. Down or up. Off you go. Great, well done. So hopefully we've got our first multiple of 100 is 9,400. We've got 9,400. The next 100 will be 9,500. Fantastic. And then when we look in our tens column, we know this is going to be 50 in the middle, 9,450. So 67 is going to be towards this side, meaning we needed to round up to 9,500. So when we're rounding 9,467 to the nearest multiple of 100, we round down to 9,400 or we round up to 9,500, but then 6 tens tells us we need to round up. 5, 6, 7, 8, 9, we round up to the next multiple. Great. So now we've had a practice with rounding to the nearest multiple of 10 and 100. You are going to complete my table by rounding this number here to the nearest 10, but also the nearest multiple of 100. Okay, off you go. Pause the video to give yourself more time. Round to the nearest 10, 762. Our nearest options are 760 or 770. The 2 tells us we are closest to 760. We're rounding that to the nearest 100. We've got 700 already. The next 100 would be 800. This time we look at the 6 tens. The 6 tens are past 50, so we would be rounding up to 800. With 322, rounding to the nearest 10, we've got 320 already. Our next one would be 330. The 2 and the 1s tells us we are closest to 320. When we think of rounding to the nearest 100, we've got 300 already, and 400 will be the next one. The 20 tells us it is lower than 50, meaning that we round down to 300. It's on its own. So we round down to 300 rather than up to 400. Then we've got rounding to the nearest 10, 1,469. So we've got 1,460. The next 10 would be 1,470. And you know 69 is very, very close to 70. So we'll be rounding up to 1,470 there. Because remember, 5, 6, 7, 8, 9, we round up. And then finally 1,469 nearest to 100, multiple of 100. We've already got 1,400. The next multiple would be 1,500. And the 60 tells us we are closest to the 1,500. So fantastic work there, year 4. That's our third and final activity complete. So well done, and thank you very much for joining me for this maths skills lesson. Stay safe, everyone.